aberration and erosion, should withstand charge load, and it should possess low permeability. Then we saw it is classified based on its resistance to various lags formed. So they are basic acid refractory, basic refractory, and neutral refractory. Then they are classified based on the composition as single oxide, mixed oxide, and non-oxide refractory. Apart from that, we see that based on thermal strength, now based on refractoriness also you can classify. The next slide is there, but this is thermal strength under load. When you talk about thermal strength and under load, classified as moderate and high and super refractory. Then based on softening temperature or refractoriness, low duty, high duty, and super duty. Okay, so we see what are the important properties of refractories. So the first one is refractoriness, and that is determined by performing a test called as pyrometric cone equivalent test, where the cone of size 19 centimeter base and 38 centimeter height is made, and one reference material will be used whose softening temperature is known, whose composition is known. So you need a reference material, and and what you see, the temperature at which it starts bending, it starts deforming, is noted as the softening or the fusion temperature. So the rate of heating is also important, because the rate of heating will also decide upon what is the fusion temperature. Because if you are heating it very rapidly, the temperature is attained first, and the material, the components are heated at a slower, like heat transfer is slow. So you find that at a higher temperature, elevated temperature, it shows fusion. If you heat it at a slower rate, then it is obtained like at a lower temperature. Just excuse me for a minute. Yeah. Am I audible to you? I think it was on.
Yes, ma'am.
Okay. Okay. So what we had seen that day was a pyrometric cone equivalent test, and that is giving you like refractoriness, like information regarding um, what is the fusion temperature. Fusion temperature has nothing to do with any sort of load. It is just heated at a specific rate, and you measure the softening or the fusion temperature. So this is the table taken from your book. I'll give you a book PDF of this topic so that you can read it properly. I might not be covering this 100% portion, So a book PDF has been made. You can go through that. Okay. So then you have chemical inertness, whether like acid refractory um, will be resistant to acidic slag, but is attacked by alkaline slags. So place where acidic slags are forming, you should use acidic refractory, and place where basic slags are forming, basic refractories should be used. Okay. Then we found resistance to erosion and aberration. Unless you have a non-porous refractory, a porous refractory will be eroded early than high bulk density refractories. Then the next important property is strength, that is refractoriness under load. So refractoriness under load is performed by performing a test called as um, like RUL test, and this RUL test is like you prepare like a specimen of 5 centimeters square area, and the height is 75 centimeters, and the load is applied 1.75 kg per centimeter square, and it is heated at a rate of 10 degrees centigrade per minute. So that is how refractoriness under load is performed. So refractoriness under load has to be good. Then only you can select that refractory, especially in case of furnace where you have like, the load is high. You can imagine that the height, if it is say 30-50 meters long, the load at this particular part will be very high. So the refractoriness under load, in no condition it should deform at that temperature and pressure condition. Okay. So strength under load is the refractoriness under load. So this is, I think, again some diagram is shown here, how that 5 centimeter squared piece of this thing is prepared, and you go for its determination. So this is the chart for one particular uh, compound, alumna Al2O3, showing you how the temperature changes uh, and how the expansion contraction of the material takes place. Then we saw what is dimensional stability. The material refractories should be dimensionally stable. It should not expand nor it should contract when the temperature furnace is turned on and turned off. But there are certain compounds, certain material which show increase or decrease in their volume. Now, for example, uh, you have quartz, that is SiO2, and you have like the arrangement of this SiO2 changes and becomes more compact, and the specific gravity uh, decreases. So, permanent expansion, it is not contracting like this is quartz. Specific gravity is decreasing, means it is expanding. Okay. So there is like expansion because the atoms are moving apart and show increase in volume. Cristobalite, further this further little bit increase in specific gravity is there. That means they are moving little compact, but not as your quartz. Okay. Then important properties like shrinkage. Now certain things will show shrinkage. Amorphous MgO, specific gravity 3.05. Crystalline Pericles, specific gravity 3.54. So like this shrinkage is because decreasing in the bond distance. Then thermal expansion. This is a measure of extent of expansion under thermal exposure. Much expansion lowers load bearing capacity. So repeated expansion and contraction causes wear and tear of rapid breakdown. A good refractory should have least possible thermal expansion coefficient. Then the next one is thermal conductivity. Now that day I think I told you, like, if this is the furnace, this is the only part Okay, so this property determines any loss or transmission of heat. The densest and least porous brick have the highest thermal conductivity. Owing to the absence of air voids, on the other hand, in porous bricks, the entrapped air in the pores act as a non-heat conducting material. Thermal conductivity determines any loss or transmission of heat. The densest and the least porous brick have highest thermal conductivity owing to the absence of air voids. On the other hand, in porous bricks, the entrapped air in the pores act as a non-heat conducting material. Generally, low thermal conductivity is used to minimize heat loss outside and thus to maintain high temperature inside. Refractories with high thermal conductivity is required where source of heat is outside, muffle furnace, coke oven, for efficient heat transfer. Choice of thermal conductivity depends on the type of furnace. Then thermal spalling, this is an important property by virtue of which refractory undergoes breaking or fracturing or peeling out or cracking. Okay, flakes of refractory material coming out. Such kind of um, uh, such kind of action is termed as thermal spalling. Now, thermal spalling, peeling out or cracking occurs because of what? Now, inside the furnace there is rapid fluctuations of temperature and development of temperature gradient. Thus, this causes uneven expansion and contraction within the mass of the refractory and leads to development of uneven stresses and strain. Good refractory should resist thermal spalling. Thermal spalling can be controlled by using refractory having high porosity, low coefficient of expansion and good thermal conductivity, avoiding sudden temperature changes by proper furnace design with uniform heat distribution. Using refractory having high porosity. Now you see this is like contradicting because thermal spalling will take place when you are using a porous material in contact with a molten slag or molten metal. Now, any molten material, whether it is slag or metal, will have a different expansion and contraction coefficient. Now, this will lead to more of cracking and peeling out, flaking out of the refractory material. So it is not desirable where you have like liquid molten metals or slags. This refractory should not have high porosity. It should have low porosity material in contact with. Now there are like, because there are different furnace operating under different conditions. That is why in every furnace you will find that these things are different. You can't say that one system, if it is okay for one type of furnace, it will work for all type of furnaces. Okay. Then heat capacity. Definitely the refractory which is lined inside should have high heat capacity. Once it is heated, it should remain inside the furnace, right? So heat capacity of any substance depend on thermal conductivity, specific heat, and specific gravity. So the specific heat is the amount of energy needed to raise the temperature of 1 gram of material by 1 degree centigrade. Compared to water, the specific heats of refractory material are very low. So these values are less than one-fourth of value of specific heat of water. Lighter weight have low heat capacity and working temperature could be attained quickly if the heat capacity is low. But when it is heated rapidly, it is cooled also rapidly. So high heat capacity is always preferred. So all refractories contain pores either due to manufacturing method or deliberately made. So you can adjust the porosity of a refractory material. Now the same material, you can have a high bulk density, you can have a porous refractory, you can have high porous refractory. So when the refractory brick is made or refractory material is made, you can adjust the air entrapment agents which will lead to which will adjust the porosity of the material. Then the porosity is the ratio of its pore volume to the bulk volume. So porosity is determined as W minus D. This W is the weight of saturated specimen. So weight of saturated specimen minus the weight of dry specimen upon weight of saturated specimen minus weight of specimen under submerged under water into 100. So this formula will give you the porosity of a substance material. Then important properties. Porosity. Porosity is an important property of refractory brick because it influences many other properties like porosity increases the resistance to thermal spalling, porosity decreases strength, resistance to aberration, chemical stability, thermal conductivity. Chemical stability, we see that penetration of molten charge, slags, gases, etc., are likely to enter more easily to a greater depth and may react, not only react, mostly it is seen that it undergoes uh, like the material is left behind and then due to contraction and expansion, thermal spalling takes place. In general, a good refractory should have low porosity. Okay. So finally, what is concluded? A good refractory should have low porosity. Then permeability. Just now we said porosity and permeability, like two things. So it is measure of rate of diffusion of a gas, liquid or molten slag to the bulk body material. It increases with rising temperature. Extent of permeability also depends on texture, porosity, size and number of connected pores and bulk density. So if the connected pores are more, then the material. So like how the pores are, that is also very important. if the pores are connected or if the pores are closed. Pores are closed and air entrapped, like circular voids are there. So such a circular voids thing will help insulate the body of furnace. But the connected pores will take away the sensible heat through them. Okay, then texture. Uh, Pores are light textured brick. Okay, high porosity and lighter in weight. Um, they show more resistance to sudden changes in temperature. However, their crushing strength is low. Such bricks are more susceptible to the action of aberration and corrosion and chemical attack. Whereas fine or dense textured bricks possess low porosity, hence are heavier in weight. They show reverse trend. Reverse trend means the like more better strength against crushing and other things. Okay, so criteria for a good refractory is it should possess good refractoriness, it should have high mechanical strength, it should be chemically inert, it should have resistance to aberration and corrosion and erosion, and dimensional. It should be dimensionally stable. A good refractory should have low thermal expansion. A good refractory should show resistance to thermal spalling. It should have optimum porosity. Now, neither high it is said nor low it is said. It should have optimum porosity. The place or job to be performed depending on that. Optimum porosity should be there, and low permeability. Okay, failure to refractoriness. Failure of refractories is internal factors are there, for example, poor refractoriness, low mechanical strength. Now, failure means under operating condition, the refractory is not able to perform its job. So that is because of a poor refractoriness, low mechanical strength, chemical reactivity, poor resistance to erosion and abrasion, low dimensional stability, high thermal expansion, poor resistance to thermal spalling, high porosity, high permeability. These are some of the internal factors. Now, external factors are improper furnace design, sudden change in temperature, improper selection, like using acid refractory when basic slags could be generated. So, such kind of things are there. Now, here we see this is a rotary kiln. Rotary kiln is a one which where cement manufacture is done. Now the length of this kiln is almost 50 meters long, and this kiln at the lower end of the kiln, like you can see, there is an angle of inclination, and the kiln rotates around it. Okay, so at this point there will be the zone of burning. So inside there will be like some charge burning over here, and from the this end, the upper end, like this is the upper end, the charge is put in and the whole thing trickles down, and the microscopic constituents are formed, and from this end you get the clinkers formed which come down here and are collected, pulverized, mixed with gypsum, and that is packed as cement in the cement manufacturing industries. Okay, now an important part, that is manufacture of refractories. Now, every refractory you will find that it is working at with different has a different manufacturing process. So now here we are discussing a general manufacturing process. For specific refractory, slightly some of the steps may change, but overall the steps are same. So the raw material for the manufacture of refractories are minerals, that is fire clay, bauxite, diaspore, mica, magnetite, dolomite, graphite, etc. You need a large quantity of fuel. a non-coking coal is used. Then you need binders, the fluxes required to bind them together the particles of the refractory. Example, organic, uh, molasses, starch, sawdust, gum, dextrine, cellulose, inorganic, plastic clay, bentonite, sodium silicate, calcine, gypsum, lime, etc. So the preliminary treatment, then blending and mixing, then forming and molding. Fourth one is drying. Fifth one is firing and burning. So what is the preliminary treatment? So the first one is calcination. The raw material is first of all calcined at 1200 to 1700 degrees centigrade in a down rod rotary kiln or shaft tunnel kiln. This removes volatile constituents and renders them dimensionally stable by minimizing shrinkage in the subsequent firing operation. Then crushing and grinding. Raw materials are then crushed. First, it is reduced to size by removing the constituents which H2O, moisture and other things. Then raw materials are crushed in jaw crusher, gyratory crushers, finely ground in hammer mill, roll mill, ball and tube mills. Okay. Then sizing. So after crushing it to fine size, it is sized. Sized means there will be like vibrating deck. On the vibratory decks, you will find that the fines of this raw material will be collected separately. The larger coarse material will be separated separately, and that is how the fines and coarse is mixed for preparation. So that if you use all coarse material, it will be like because whites will be there in between if you are using the coarse material. If you add fines to the coarse, like larger particles, if you add very fine particles, the fine particle will trap the interstices and the voids will be filled up. Okay, so coarse material is recycled for further grinding for fineness. Then beneficiation. The term itself indicates that you are benefiting your mineral. If raw material contains any undesirable impurities, they are beneficiated by the process like magnetic separation. Refractories. This is important. Then coming to the next step, that
Ma'am,
is blending and
please
mixing. Yes,
explain sizing.
sizing. Sizing is like what is done. See, you excavate from the
Ma'am,
earth
please explain.
crust. Sizing only I am coming. First, you go for calcination, then crushing and grinding. So, crushing and grinding is like not all will be pulverized to a fine size of micron. Okay, so like depending on like what material you are manufacturing, you go for changing, taking the sieves. Okay, 100 micron sieve, 10 micron sieve, millimeter sieve, then centimeter sieves, 1 inch sieve, 10 centimeter sieve. So all those material which are not sieved by a 1 centimeter sieve, that will be again put for crushing and grinding. So how to decide that? So you are going for sizing. So without sizing, you can't segregate the fine material, the medium size lumps, and the coarse material. Coarse means बड़े बड़े पत्थर पत्थर ये नहीं like जो भी आपका raw material है उसका जो बड़ा बड़ा size है that is the coarse material. So after crushing and grinding उसको sizing किया जाएगा.
Okay,
Ground
ma'am.
raw material are sized into coarse. कोर्स यानी बड़ा बड़ा साइज का,
Hmm.
मीडियम यानी मॉडरेट साइज के पार्टिकल्स, फाइन्स यानी एकदम से फाइन पाउडर जैसे आपका नॉट लाइक सैंड बट लाइक योर व्हीट फ्लोर. ओके, So that you can term as fines. ठीक है? तो sand का कैसे, अब sand particles बड़े होते हैं. Then even sand you must have seen, for construction you remove the larger particle, coarse particle is removed for plastering and all. So something like that. तो ये तो बहुत लार्ज स्केल में होता है. तो देर आर डिफरेंट वाइब्रेटरी डेक्स, यानी ऊपर से नीचे तक मटेरियल आएगा, हर लेवल पे एक बड़ा बड़ा सीव रहेगा. यहाँ पे डायग्राम है क्या, आई डोंट नो. डायग्राम्स भी मिल सकते हैं बट इज नॉट पुट हियर. दैट विल क्लियर योर आइडिया. वाइब्रेटरी स्क्रीन्स यानी मेश होता है ना, जाली, जाली जिसको कहते हैं छानने का, दैट. ओके, तो यूजिंग दैट इट इज साइज्ड. तो साइजिंग करने से क्या होगा कि आपका जो फाइन मटेरियल, बारीक मटेरियल है, वो सबसे नीचे रहेगा. मीडियम साइज का, मीडियम साइज के जाली से जो रिटेन हो जाएगा वो रह जाएगा. सबसे ऊपर में जो सबसे बड़ा बड़ा पत्थर है वो अलग हो जाएगा, या जो भी रॉ मटेरियल है आपका, राइट. तो
Right, ma'am.
कोर्स
Okay, ma'am.
मटेरियल इज रिसाइकल, यानी जो बड़े बड़े पत्थर है उसको वापस भेज दिया क्रशिंग एंड ग्राइंडिंग के लिए. रिसाइकल फॉर द ग्राइंडिंग एंड फाइननेस. ठीक है. फिर बेनिफिशिएशन. इफ रॉ मटेरियल कंटेन्स एनी अनडिजायरेबल इम्प्योरिटीज. हाँ, तो ये फिर से एक स्पेसिफिक है. जैसे आप फायर क्ले रिफ्रैक्टरी बना रहे हो, मैग्नेसाइट रिफ्रैक्टरी बना रहे हो, डिपेंड्स ऑन व्हाट रिफ्रैक्टरी मटेरियल. तीनों के तीनों एक पर्टिकुलर रिफ्रैक्टरी के लिए नहीं यूज होंगे, कोई एक मेथड यूज होगा. ओके, बिकॉज दिस इज अ जनरल प्रोसेस, इट इज कंप्राइजिंग ऑफ ऑल टाइप ऑफ स्टेप्स. देन कमिंग टू ब्लेंडिंग में, अभी क्या हो गया आपका, लाइक ये जो अलग अलग साइज का मटेरियल अलग कर दिया था, अभी आपने फाइन, बिल्कुल फाइन पाउडर जो है वो, और मीडियम साइज का जो है, दैट यू आर टेकिंग, सो दैट इट हैज, ये फाइन इसके बीच बीच में जाके इसका कंप्लीट फिल कर देगा वॉइड्स को. तो ब्लेंडिंग एंड मिक्सिंग. नाउ रॉ मटेरियल इज मिक्स्ड. अब मिक्स करने के बाद इट हैज टू बी like made into a dough, so you need to add some water. Okay, so raw materials of correct size distribution are blended with bond additions and water to obtain the final product of desired porosity. आपको जो porosity चाहिए उस porosity का मटेरियल के लिए you have to select the raw materials. Okay, for low porosity refractory, selecting proper particle size, interstices between particles are filled by finer buds. There are some disturbances today. So we were on blending and mixing. So for low porosity, you use more of fines. For high porosity, you use more of coarse material. बड़ा बड़ा particle ज़्यादा use करेंगे, तो voids रह जाएंगे उसके बीच में. So type and percentage of bond additions depend on type of refractory, ordinary or porous. The quantity of water depends on type of molding process. अब उसमें कितना पानी डालना है, it will depend on वो हाथ से मोल्ड कर रहा है तो सबसे ज्यादा पानी रहेगा. हैंड मोल्डिंग ब्रिक्स अगर आपने कहीं पे देखा है, if you have seen, like more of water will be there. So 10 to 20% of water is mixed. If you are going for extrusion or repressing or pressing sort of thing, extrusion means like from one side.
Ma'am, you are not audible.
Okay, so we saw main function of blending and mixing are. Can you hear me with this noise coming? Yes. Is there anyone? Yeah, can you hear me?
Yes, ma'am.
Yes, ma'am.
अभी आवाज
Yes,
नहीं
ma'am.
है, but when the noise is there, na, it's very difficult. Main function of blending and mixing are controlling the porosity of the final product by reducing the air entrapped in the interstices, producing a homogeneous mixture of batch ingredients.
Disturbances, ma'am.
Okay, we come back here. Blending and mixing. So you can control the porosity. You can go for producing a homogeneous mixture of batch ingredients, distribution of plastic material to coat thoroughly the non-plastic constituents, thereby developing plasticity. The material will be pressed into the mold. Semi-plastic mixes having 10 to 15% water are horizontally extruded under moderate pressure to a die of desired shape by a de-airing auger. So de-airing decreases the lamination and cracking of the brick and increases density. Dry pressing produces refractory of high strength, density, and uniformity for 3 to 7% water mixes. Mix is pressed under pressure of 30 to 150 newtons per meter square. Then slip casting, suitable for intricate shapes with thin sections. A stable suspension of finely powdered mix in water is poured onto a plaster of Paris mold. Then drying. The whole thing, what all article has been made, or pipe, or crucible, or a brick is prepared, that is uh, put for drying. So for drying, there are different type of dryers. So the Purpose is to remove the moisture added to develop plasticity in the mix. Rate of drying should be slow under selected set of humidity and temperature conditions so that no voids are left in the refractory nor cracks are produced due to internal stresses developed because of shrinkage. Three types of dryers are employed: hot floor dryers, soft mud refractories are used there, tunnel dryers used for bricks and small shapes. The green shapes are set on trolley which move in the tunnel. The tunnel dryer will keep moving around. Then controlled humidity dryers. The tunnel is set to controlled temperature and humidity. So under like where you don't want any crack to develop, because if the drying is very rapid, not in certain humidity condition, then you get formation of cracks in that. So in such for such refractory like crucibles, especially crucibles and all, will be cooled, dried in that particular controlled humidity dryers. Then burning and firing. This is the most important step where the refractory brick is fired or the refractories prepared are fired by burning or firing. So important function of firing are development of a permanent bond by partial vitrification of the mix, which imparts mechanical strength to the refractory. So the second one is development of stable mineral forms to give a permanent set at dimensions that will not change appreciably in future service. So chemical changes that takes place are: first one is removal of water of hydration, second second one is calcination of carbonates and oxidation of ferrous iron. So up to 30% shrinkage in volume may occur, which may develop severe strain. To eliminate this, pre-stabilization of material is performed, example by sizing and pressing. So the preliminary, the earlier steps are also important, like your forming and drying, the rate at which it is dried. Later on, when it goes for burning, such kind of stresses are not developed if the drying part is performed properly. So the drying, the burning or the firing is done in a rotary, like there is a round down draught periodic clean. So this is why round, because from the top view it will appear round. Now this part is round and the firing box is also arranged around it like this round. From all sides, at least from 6 sides, there will be such burners on which the coal is burned, and down, because the hot flames descend down in this direction, there will be an hearth over which all your refractory bricks will be placed here. Okay, so all refractory bricks will be placed here and the hot flames will burn the bricks. Draught because it is dry, periodic because it is not a continuous clean, it is a periodic clean. One stack is kept burnt for 15 days or 3 weeks, and then the refractory brick is taken out, and then again. So such kind of a clean is used mostly for bricks. So firing technique and schedules vary with the type of refractory being manufactured. Three types of cleans are used: round down draught periodic clean, continuous chamber cleans, continuous tunnel cleans, and muffle cleans. Cleans means the place where very high temperature is maintained for a longer time. So any such furnace where uh, furnace where some commodity is manufactured at high temperature, they are termed as clean. Okay, so continuous chamber clean, continuous tunnel clean and muffle clean. And for bricks, they are using round down dot periodic clean. Okay, so this is in short a flow chart sort of thing prepared for your raw material, and then calcination, crushing, grinding, sizing, beneficiation, and storage. Then you go for preliminary treatment, then blending and mixing. It is performed to develop plasticity, to produce homogeneous mixture, control porosity. Then molding. Molding, you have two methods, manual and mechanical. Manual is stiff mud process, mechanical is dry pressing and slip casting. Then drying. Drying, removal of moisture. Drying is usually carried out in tunnel dryers or hot floor dryers. Firing, burning. Final step. The bricks are generally fired at a temperature um, as higher than their use temperature. Okay, so it develops strength, vitrification, and to develop stable mineral composition. Some chemical change may occur. Ferrous or ferric, like removal of water, of hydration, etc. It is done to in tunnel cleans or shaft cleans or rotary clean. Then packaging. So this is the chart where different type of refractories. Now fire clay refractory has a composition Al2O3, SiO2. These are the percentages, fusion temperature, and use where they are used. Then high alumina refractory Al2O3, SiO2, 1700 and 1750. Lining of hot metal mixtures. Generally, this thing is not as this is kept only for your understanding and knowing that in which type of um, furnace and all you are using which type of clay, which type of refractory material. Okay, and these are two textbooks from which you can read this particular topic. Okay, so for today we stop here, and with this the refractories topic is over. It's a small topic. What is important is what are the requisites of a good refractory material, the questions that can be there, requisites of good refractory material, then properties and manufacturing process. Things are clear?
Yes, ma'am.
Okay, so
Yes,
there
ma'am.
was some disturbance,
Yes, ma'am.
sound disturbance today. Okay, so with this, the refractories topic is over. Tomorrow we will start with adsorption. Okay, and today Viva will be there for X2 batch, and tomorrow after the theory class, I'll take Viva of X2. No, today you have Viva for X3 batch, right? So X3 batch, I'll send a fresh link at 2 o'clock. 2 to 4 we will finish the X3 Viva, and tomorrow we will try to cover the portion, the Viva for X2 batch. Second half, are you free? Tomorrow is Saturday. X2 batch students, are you here?
Yes, ma'am.
Yes, ma'am.
So
Yes,
what
ma'am.
time you are free tomorrow?
Yes, ma'am.
Yes, ma'am.
2 to 4?
Okay, ma'am. Yes, ma'am.
Yes, ma'am.
We have theory class tomorrow 12 to 1. If it is possible, I'll continue at like I'll give you 15 minutes break. I'll start at 1:15 because now you don't have to rush to the canteen, like to the mess, right? If you had been to the in the college, 1 to 2 we never take anything because you have to rush to the mess, have your lunch, and come back to the lab or to the department. So going to the mess 5 minutes, coming back 5 minutes. So now you are at home, so you can have your lunch anytime, right? Before or after. So I'll start at 1:15 itself. Things will do.
Ma'am, after half hour.
After half hour. Okay. So 12:30, 1:30 we should start.
Yes, ma'am.
Okay. So we start at 1:30, and this is X3 batch. So X3 batch, I'll start from first or last part. First part only. Like the initial roll numbers will start. For X1, I started from backside, like 24, 22 roll numbers. Now I'll start with your roll number start from 49.
Yes,
Today
ma'am.
49. Tomorrow it will be 25 onwards, right? Okay, we'll see. Today also I'll send you another different link in your email. You will join to that.
X3 Viva will start at 1:30 then.
X3 Viva is starting at 2 o'clock today, and X2 Viva tomorrow it will start at 1:30. 1:30. Because tomorrow is Saturday, we have a class 12 to 1, and then you are free. So X2 is remaining for the Viva. We'll start at 1:30 and we'll get over by 3 o'clock. Clear? Then
Will you
remains
send this
yesterday's.
PDF?
Z1 batch is remaining. Yes?
When you will send them PDF ma'am, book ma'am?
What?
This refractories ma'am.
Refractory book PDF.
Yes ma'am.
You want book
When you will
PDF? I'll
send them?
put it on the WhatsApp group.
Okay.
Okay?
Today ma'am? Okay.
Excuse me, ma'am.
Yes?
Ma'am, I have a doubt. Which indicator is used in titration of Na2CO3 against HCl?
Okay. Okay, so you people are reading now. Hmm? Okay.
No, ma'am. Actually, I was having this doubt in from many classes, but I wasn't having the guts to ask for real.